Okay, let's get started. Welcome back. I'm having some slight technical difficulties. For some reason, my keyboard doesn't seem to be responding and my clicker's not responding, so I may have some difficulties with the slides, but hopefully it won't be any big deal. A few announcements first. Monday is a holiday. My office hours for the problem sets are on Monday. I will not be taking a holiday on Monday, so I will hold my regular office hours from 11 to 12 in my office, which is 697 Evans, if you would like my help with the problem set. Or, actually, more to the point, if you would like the help of the other people who show up to my office hours, which is how I tend to do things. Okay, a reminder about the screencasts. The screencasts, other than from the first lecture, are going to be posted on the website that you have a link to in the syllabus with an 8-day delay. The idea being that you can get access to them after you've turned in the problem set that they relate to. The Tuesday before an exam will always be a review. That screencast will be posted immediately. And then there's the Thursday before an exam, right, where an 8-day delay would take it past the exam, and that would be not very helpful. So that one will be available Wednesday morning right before the exam on a shorter delay, a 6-day delay instead of an 8-day. And then I was told by the screencast people, or the webcast people, that Tuesday's screencast didn't have any video for some reason. So I apologize for that. Please do not use laptops. Sorry, let me rephrase myself. Do not use laptops. Unless you have specifically asked me about this and have some sort of learning-related reason that you must take notes for this class with a laptop, please do not use a laptop. It is not only distracting to me, but it is distracting to other people. And if that creates a hardship for you from the standpoint of learning material in this class, please speak to me. Okay. I want to say one other thing. I was just asked before the beginning of the class if I was going to finish up the example of buying and selling prices for mugs under reference dependent preferences. I'm not. I know that at least one of the GSIs, and I think that they're coordinating their stuff, so maybe the rest of them will as well. I think that the GSIs are going to go over that. It is almost identical to Part A of Problem 1 on the problem set. So take a stab at it. If you find that doesn't that it doesn't make sense to you, post a question on the forum. Someone's got to break the ice on the forum. I don't think it's been used yet. So please do that. The goal here is that by the end of the problem set process, some learning should happen. So don't be afraid to say, I've tried and I can't figure this out. We will help you. Okay. So what we're going to do today is we're going to cover a couple topics. Sort of finishing up the basic, my basic presentation of reference-dependent preferences, where there's no risk or uncertainty involved, and which we're going to get into soon, and where there's no future or past involved, which we're going to get into in a little while. Just the basic issues. I'm going to finish up that presentation by talking about what I've been sort of alluding to for some time, which is this question of rationality and how how reference dependence can violate rationality and the implications of that. And we'll see some other different places where reference dependence shows up. And then we'll start talking about reference dependence in consumer markets. One of the big sort of debates or points of contention in sort of between quote-unquote the sort of standard model camp and the behavioral camp is this idea that, okay, maybe there are all these ways in which people are kind of goofy or irrational, but competition in markets should take care of it the same way that competition in markets takes care of firms that aren't rational profit maximizers because they're so broke. So we'll take a look at some evidence and see whether or not we think that's right. However, before we do that, I just want to review something that I feel like I presented not very effectively last time, which is this sort of graphic presentation of the reference-dependent value function with loss aversion. Okay? So normally, when we map from consumption to utility, right, we have C here, and we have U of C there, where C could be money, or it could be mugs, or it could be absolutely anything. It could be the number of years you expect to live, or it could be the number of crimes committed in your neighborhood on an average week, that kind of thing. And normally what we do is we just say whatever your consumption level is, this is 0, say 0, you have 0 mugs, and any number of mugs above 0 is moving you that way. Here we're not measuring consumption by itself on the horizontal axis. What we're measuring is gains or losses relative to the reference point, right? So this central intersection is the origin, it's 0, but it's not 0 mugs. It's 0 gain or loss in mugs, okay? So if your reference point, let's say that you have a consumption level of 10, you have right this moment, you have crowded onto your desk 10 mugs. They're small mugs, maybe they're espresso mugs, I don't know. Right? So if your reference point is 10 mugs, that is what I'm expecting to have in some sense, or that's what I've had for a while, then C minus R is going to be equal to 0, and you are here getting no gain loss utility, right? If that's our gain loss value function, right, this axis is V, not of C, but of C minus R. It's the utility you get for gains or losses. So if you walk in the door actually thinking of yourself as someone who does or is supposed to or soon will own 9 mugs, then obviously C minus R is a gain, and you're here. Same exact number of mugs sitting on your table, different point on this graph. This is the fundamental difference between that model and this whole Hicksian model, right? Is that here, like, if that's 10 mugs, doesn't move around, 10 is 10, okay? Here it moves around depending on what your reference point is. Okay, so hopefully that clears up, because I think some people went away not super clear on how that graph works. But that's just the graphical intuition behind that value function, where we're going to typically assume in this class something like this is just V of C minus R equals C minus R, and this is V of C minus R equals 2 times C minus R, right? So we have this kink. Okay. All right, so now let's talk about rationality. And as we're going to do over and over again, we'll start by sort of backtracking to this is going to be a little bit annoying. I'm going to have to be switching back and forth between the arrow and the pen in order to advance the slide. Okay, so we're going to back up a little bit to talk about the standard model, and then we're going to bring in the behavioral comparison. So let's remember what rationality actually means in Hicksian utility theory. Now, rationality means a lot of things in the English language, a limited subset of which are things that it means in economics, right? So if you look up rationality online, whatever dictionary.com, you don't get any of the economics definitions, right? You get definitions that have to do with reasonable or sane, blah, 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 blah. And except sort of implicitly and in a very loose sense, none of those definitions have anything to do with technically what we mean in economics when we use the word rationality. We don't mean that people are reasonable. We selected the word to describe what we mean because we think that our definition of rationality is reasonable, but we do not mean that people are reasonable. We mean, when we say that people are rational, that they obey very, very specifically, mathematically defined rules of decision making. Okay? And we're going to talk about 3 different sort of definite meanings of rationality, versions of rationality over the course of the semester. We're going to talk about rational preferences, rational expectations, and rational self-interest. So what we're talking about now is rational preferences, which you learned about in chapter 4 of Nekiba. And it means 2 things, right? It means if your preferences are rational, it means that they are complete and they are transitive. Let me just remind you what those things mean. If you have some choice set, right? It could be consumption bundles, it could be different models and colors and make, year of car that you could choose from, it could be different marriage partners, blah, blah, blah. And and we're going to randomly select two elements from within that choice set, A and B. Completeness simply means that either A is preferred to B, or B is preferred to A, or since this is the weak preference relation, right, preferred to or equivalent to, if A is weakly preferred to B and B is weakly preferred to A, it simply means that you're indifferent between the two. So all that means is that you can define some preference relation between all objects in your choice set. There's no object in there where, if I said, would you rather marry this person or that person, you would look at me blankly and say, I don't know. You might say, I don't care. That's the indifference relationship, but you would never say, I don't know. All right. Then there's transitivity, which says that if we randomly select 3 items, A, B, and C, from out of your choice set, whatever that choice set happens to be, if it's the case that you weakly prefer A to B and weakly prefer B to C, then it better be the case that you weakly prefer A to C, right? If you are more attracted to Johnny Depp than you are to Harvey Keitel, and you're more attracted to Harvey Keitel than you are to George W. Bush, then you better be more attracted to Johnny Depp than you are to George W. Bush. Okay? I don't know if it works in that case, but that's what it means. Okay? Now, let's talk about why these two things taken together would be thought of as some kind of definition of rationality when it comes to how you choose. Okay? Assuming rationality, if you go back and read Nakaba, what he's going to say to you is, well, if transitivity is violated, then I could pump money out of you by first offering you a choice between A and B plus a little bit of money, and then B and C plus a little bit of money, and then C and A plus a little bit of money, and they can just keep cycling and squeeze money out of you. And that's true and that's crazy, but that's not the main problem with violations of transitivity. The main problem is that if you don't have transitivity in your rankings of things, you actually don't have a consistent ranking at all. And we don't have any way of determining what you like best. All of neoclassical microeconomics is driven by the idea that we can mathematically model the optimization process by which you choose the thing you like most. And if you don't have transitivity, you don't have a consistent ranking, you don't have a most. Okay? And all of neoclassical microeconomics is dead on arrival. Right? Collapses under, it just becomes completely impossible to mathematize consumer choice at all. So let me give you just very simply what I mean by that. I'm just going to skip right on the screen because it's going to have to, I don't want to switch back and forth. Let's suppose you have a situation where you strictly prefer A to B, and you strictly prefer B to C, and you strictly prefer C to A. And then I say, all right, well, check this out. Which of those things would you choose? From among a choice set of A, B, and C, which do you choose? I mean, should we take a poll? You can't do it. Right? You can't do it. The way we model choice, hang on 1 second, Alex. The way we model choice is that first we assume that you can rank things in some kind of ordinal manner that is consistent and meaningful, and that then you will choose the one on the top. There's no top if you don't have transitivity. Alice. That's just reframing the model. That's what Gould and Pessendorfer do when they try to dodge around some of the time inconsistency stuff that behavioral economics have come up with. If I can't prove you that there's rationality in the choice I actually care about, I'll just reframe my model so that it's about some choice that isn't what you were really talking about, and then all of a sudden I get rationality back. I mean, let's say that the choice set is marriage partners. There are 3. You get to marry one of them. You don't get to marry all 3 of them. You have to. I mean, you're not legally, or So subject to constraints, you can't do it. Okay, so rationality it's really, and this is more than just about the link between positive and normative economics. I mean, the whole system breaks down. The whole mathematical formalization of neoclassical economics falls apart. You can't do it. Okay, so that's rationality. So graphically what that means, and sadly I think this isn't in Nakaba, but let's go back, and we're switching by the way, just keep track of this. Sometimes I'm graphing consumption against utility, and sometimes I'm graphing 2 different dimensions of consumption. So let's go back to, I mean, it doesn't. I'm going to say months versus money. It doesn't matter anything, right? Any 2 dimensions of consumption, and just sort of see how transitivity turns into conditions on indifference curves. So let's just have 2 points here, 2 different bundles, A and B. Okay, and without an indifference curve, even under the assumption of monotonicity, which is that people like more of everything better, we don't actually know which one of these things we prefer because one's got more money, less mugs, one's got more mugs, less money. Okay, but as soon as we draw in an indifference curve through one of these points, we can say something about preference, and specifically what we can say is that A is preferred to B. Okay, if I now draw in a third point C, I want my C there. I can't say anything. So this indifference curve tells me exactly what's going on, right? Because it sort of is the beginning of this ranking process. And so I can say that for sure B is strictly preferred to C. I could have said that without the indifference curve to some strength of monotonicity because B has more money and mugs. But with this indifference curve, it's absolutely unambiguous that B is strictly preferred to C. And if you have transitivity, A is clearly also strictly preferred to C, right? That's what we get with transitivity. But what if you actually found by observing people's choices, that there was you mapped out their choices in real economic decisions and found that there was another indifference curve that went through C and went above A. Okay? Now what you've got is that basing your analysis on this indifference curve, what you have is that C is strictly preferred to A. Okay? Breakdown. So if indifference curves cross, then there will be a violation of transitivity. Therefore, this is what's called a proof by contradiction. So the first thing I did was I contradicted the statement, which is indifference curves don't cross, okay, by saying, well, what if they do? And then I showed that transitivity can't hold. And that means that if transitivity holds, it must be the case that indifference curves don't cross, okay? So that's a sort of graphical proof by contradiction. Now, we will, in the grand scheme of trying to turn economics into a real science, we will now resort to the facts. Yes? Tell me your name. Pedro? Pedro.
So, how do you prove that such a thing can happen? Because
we're going there. Facts. Whoops. Yes, we're gonna test it. Okay. So we have a prediction. We based our model of reference dependence on having observed the endowment effect. Then we used that model of reference dependence to sort of come up with a crisp set of predictions. The Hicksian model says you will never get crossing indifference curves. Okay. The reference dependent model actually makes it possible for curves to cross. We have a crisp way of distinguishing these two models based on things that we can go and observe. Now we're going to observe them. Okay, Knecht, right? So the assigned reading is Kahneman, Knecht, and Thaler. We've met Kahneman already. He's the Nobel Prize-winning psychologist who turned into, effectively an economist by basically inventing behavioral economics for us. Knecht is emeritus at Simon Fraser University up in British Columbia, and his primary interest is actually cost-benefit analysis and the behavioral economic implications for cost-benefit analysis, which we'll talk about in a couple of slides. So he did a sort of follow-up to the stuff that you saw in the assigned reading. He randomly endowed subjects, so he split these subjects into two groups. Now let me just tell you in advance, the subjects, somewhat bizarrely, were mothers waiting for their children to get done with swimming lessons at a public swimming pool. So whatever, just, you know, we're trying to get out here into the real world a little bit. He split them into two groups. The first group he endowed with $4.50. I'm assuming that's Canadian, and this was back, it's published in 92, but he actually did the experiment like in the late 80s. Group 2, he gave 5, quote-unquote, reasonably high-quality ballpoint pens. Now, this is at a time when 5 reasonably high-quality ballpoint pens was going to cost you in the store about $4.50. Okay. Then he did this willingness to accept, for each group, right? He's given them an endowment, and then he's going to take away one by one the items from their endowment and ask them how much of the other item they would need to be paid, their minimum willingness to accept the other item in exchange for the thing he's taking away. And the difference between this experiment and the ones in the paper that you've been assigned to read is that in the paper, the endowment is always just one mug or one candy bar or one token. And here he's going to do a series of them so that he can actually map out a whole indifference curve, right? So what he's going to do is if this is pens and this is money, then group A was the ones he gave money to, right? So he gave these folks a bunch of money. He gave them $4.50, and I don't remember the increments, but he basically said, if I took one of those away from you, I don't know if it was dollars or 50 cents at the time how I did it, how many pens would I have to give you, right? And so he maps out sort of this some kind of difference curve like that for these folks. Although actually I think on his graph he's going to assume that they already own some ballpoint pens, so he's going to start it out here somewhere. And then the same thing for pens. He gave a bunch of people pens and asked them, right? So how many dollars would you need to be paid to give up one pen at a time? And then he graphs the difference curve, which I'll show you in a second, which you've got in front of you already. You know the answer already. There's no income effects, right? The fact that these pens are worth $4.50 means that there's no income effects here. The fact that these mothers have different incomes also means that this is probably not about the income effect. And that's what he got. So he mapped out sort of the average indifference curve implied by the answers for the people that he gave the money to, and the average indifference curve for the people that he gave the pens to, right? And it looks like, yeah, that's right. Sorry, right. So here's 5 pens, no dollars, and here's $4.50 and no pens. So he's just got the axes reversed from what I have. Why did he do average? What is this average indifference curve? We're not talking, our neoclassical microeconomics is not based on average indifference curves. It's based on individual preferences, right? That's a fundamental methodological assumption of individualism. What's he doing? Why is he doing averages? He's comparing two groups, not two individuals. Why wouldn't he just take pairs of individuals within those groups? Right, so Pedden's answer is because they're randomly selected, we don't know what the corresponding, if you take someone out of group 1, what you'd really like to do is to compare them to the identical person in group 2, because you don't know who that person is. But what you do know, because you've randomized, is that on average, they're identical, right? The group averages should be, the distribution across in the group should be the same. So their average should be the same, their median should be the same, and their 90th percentile should be the same, their variance should be the same, et cetera, et cetera, et cetera. But among individuals, you don't know how to compare. So just because I want to sort of try to run a thread of experimental economics through the class, this is the difference between what's called a between subjects design and a within subjects design, okay? This is a between subjects design. We got two different treatments. What we really want to know isn't how a group with treatment 1 and a group with treatment 2 compares. What we really want to know is how a specific individual would respond if we took them from treatment 1 to treatment 2. But the only way to do that with a specific individual is to first give them treatment 1 and then give them treatment 2, which means that at the time that you give them treatment 2, they are a different person than at the time you gave them treatment 1, and you do not have identical comparison, okay? So within subjects comparisons are extremely problematic experimentally. You can't actually compare apples to apples in a within subjects treatment unless you are A, lucky, or B, very careful. By and large, you run into these problems. How do you typically do that? Is that you have a large group, and you do treatment 1, treatment 2 for half of them, and you do treatment 2, treatment 1 for the other half, and check to see whether the order makes any difference. And if it doesn't, then you're okay. Clever design makes a big difference, because obviously a convincing within subjects experiment is going to be more compelling scientifically than a between subjects for certain kinds of questions. However, for my money, this is pretty compelling, right? The slope of indifference curves is dramatically different depending on whether you first endow them with pens and ask them their willingness to accept in exchange for money, or first endow them with money and ask them their willingness to accept for pens. Okay? Jack Netsch published this article under the title "Non-Reversible Preference Curves." Indifference curves. What I actually think is more interesting is that these indifference curves violate rationality. Okay. That's doing pretty good. All right. So no rationality. What's the problem? Where does this really start to cause us problems? So remember from the first lecture, I sort of said that part of what I'm going to try to point out throughout the semester is the way that rationality links so positive and normative economics, but more specifically, the positive uses that the positive ways that we use our models and the normative ways that we use our models, right? So the positive ways that we use our models are to predict what will be the buying price, what will be the selling price, how many mugs will be traded. And I hope that I've convinced you that a model with reference-dependent preferences does a dramatically better job of predicting what people's actual behavior will be than the standard Hicksian model without reference dependence, right? At least in the mugs market. Normative economics, we use the same model to do normative economics when we ask questions like, does it matter who we give mugs to if we allow them to trade? What would be the social welfare impact of imposing a tax on the market for mugs?